All right, so that concluded 1.2. 1.3 is subtracting integers. So subtracting integers. If you like to show the subtraction, that's great. I generally show this with addition, actually. And the reason is because we get used to those rules with addition. Now, if if this first problem, let's say that instead of 5 minus 9, let's say that we had 9 minus 5. Okay, in this case, I would say do 9 to minus 5. That's pretty good. And you could say, well, I know the answer is 4. That is awesome. All right, this one comes out. It's convenient. It's something we probably used to. The difference is I'm taking away more than I start with, because I would say in this case, I'm going to start with 5, and I'm going to take away 9. Well, 9 is too many to take away from 5. Well, I shouldn't say it's too many. It's just more than we have to take away from. Now, again, that is why the answer is going to be negative, which is why it may be good to see this as a fact family from 5 plus negative 9. Now, again, it's not required that you show it this way. It's a good thing to see, though, even if you guys are kind of confused about this, because in the future, when we start looking at equations and expressions with letters, this skill of adding negatives is going to be pretty important. Okay, so to understand that this minus 9 is the same thing as adding a negative 9 will be very crucial. Okay, but if you're like, well, I know 5 minus 9 is negative 4, that's fine. Okay, in the meantime, though, just looking at what we have in purple there, 5 plus negative 9, I would see that I have more negatives than positives with an addition problem. And then I would do 9 minus 5, which is 4. So that answer is negative 4. Now, again, there's something else I want to point out here. In the beginning, we did that 9 minus 5, which was positive 4. If you switch numbers around with subtraction, like we did with this one, 5 minus 9, 9 minus 5 became 5 minus 9. It's still the same number, it's just changed the sign. It's the opposite. Right, so this one's 4, this one's negative 4. So it pretty much works on all the problems. So I do this often when I look at homework from other classes like 1010 or 980. If I type it in wrong, I just know to change this. All right, now that was 5 minus 9. I want you guys to try this 8 minus negative 4 thing, okay? Just try 15 seconds, okay? See if you can figure out the answer to this one. All right. Now, hopefully you guys got this one correct, okay? But if you didn't, it's okay. There's a couple different answers we get when we show this the first time. One of them is 4. Another one's negative 4. Another one's negative 12. Another one is 12. Usually those are the 4 most common answers we get from a problem like this one. Now, if we consider what is actually happening here, and you don't have to like this, we're just going to show it a different way here in a second, but minus a negative, okay? Minus a negative means that we're going to take, the negative is an opposite, right? So opposite. It's the opposite of what? Well, it's the opposite of 4, but it's also the opposite of this minus. Opposite of minus, which is what? Opposite of minus is addition, which means I could rewrite this as 8 plus 4. Okay, these have the exact same value. Now remember what we talked about in 1.0 is changing math expressions to be what we would like to see, because most students, well, even I don't like to see minus negatives. I would rather see 8 plus 4 than 8 minus negative 4, okay? There are some times where you may want 8 minus negative 4, but when we're just straight calculating like this one, showing it as 8 plus 4 for me is a lot more convenient. And I know 8 plus 4 is 12, which means 8 minus negative 4 is also 12. Because again, we've manipulated this into something that is easier for us to do but it gives us the same answer. It's still equivalent. So just to kind of reiterate that, if you see minus a negative, what I usually do, and just so I don't get things confused, is I just make this really big right there and make it a plus, and then I know it's 8 plus 4. Now if we went back, let me go back here. I don't know. I have heard this called the KISS method, which is just KSS. Keep, change. I apologize. Keep, change. So you're going to keep the 8 and 8. You're going to change this one and change that one. Okay, it's the same thing. It's just showing 8 plus positive 4. Personally, I just like to do what I did in red there by changing it into a big fat plus sign. And it looks good. I don't get things confused. But some people remember this keep, change stuff. Some students have remembered it from high school or junior high or whatever. So when we subtract integers, usually we do it vertically. And yeah, when we take away too much, we borrow. And sometimes we need to borrow. But adding a negative is the same thing as subtracting a positive. So in this example, 8 plus negative 4, you could have written it as what we have here at the bottom, 8 minus 4. Because that's 8 minus this positive 4. Of course, again, you could show it as 8 plus negative 4. Again, it depends on the purpose or what you are trying to get out of it. If you need to manipulate it in such a way that this one's easier for you to do, then do it, okay? All right, using temperature to understand subtraction. This is really just like the counter method. So if we went and looked at just a basic example. Let's say that we had 6. We'll kind of use smaller numbers. Let's do 6 minus 2. And I have the 6 and 2. They're both positive, so I'm going to keep those black. Now the counter example, right? So we would say that a black counter would be like the same as a positive 1 degree. And we use red as a negative counter. So this one would be like a negative 1 degree, right? Excuse me. Now there's no negatives in this particular problem, but it's like saying, well, in a pot, and yes, my pot here is going to be a square pot. They're usually cylindrical, but mine is rectangular-ish. I'm going to start with 6 of these positives, 1 degrees, right? So inside of my pot of stew, or whatever the crap this is, math stew maybe, there are 6 positive counters. Now in these 6 counters, the problem is telling us to take away 2, right? So I could take, let's say, these 2. If I took them out, I'd just erase this garbage. That didn't really work. Let me see if I can find a different way to erase it. Where the heck did it go? There we go. I took those 2 out. Right, well, what's the new temperature inside the pot? Well, that would be positive 4, because there's 4 positive 1 counter temperature cubes, whatever, inside the pot. Now that was great. It was a great example. But this time inside the pot, let's say we're going to do, I don't know, 7 minus negative 3. Now, to demonstrate this, and this is where things can get a little confusing, not that we want it to, but I need to start with the value of 7 inside the pot, 7 degrees, right? Now, to do that easily, we could just do 1, 2, 3, 4, 5, 6, 7 of these positive counters. Now, for the problem, though, it says that I need to take away 3 negative counters, right? But I'm not showing 3 negative counters, but I do want a temperature of 7. So that means if I put in a negative degree, I need to tack on another positive degree to maintain the equality part on that, right? So if I tack on 2 more positives, I need 2 more negatives. Again, the total value of the pot right now is still 7 because the red counter is going to cancel out as a 0 pair one of the positive ones. So it says to take away 3 negative counters. Well, I got 3 now right there, right? So I'm going to take those out by just erasing them. See if I can do that properly. That's okay. All right, so I took out those 3 negatives. And what's the total temperature in the pot now? Well, we can see that it is positive 10. Just count them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's 10 positive counters, which again goes back to what we were saying. If you see minus a negative, I usually just change that to a big positive plus sign. 7 plus 3 is 10. It's the same exact thing. Now, if you hated that, well, we're never going to ask you on a test to say use temperature or counters to demonstrate subtraction, okay? But hopefully this helps you to understand why subtracting negatives ends up being addition. All right, if you're adding a negative, it's the same thing as subtracting a positive. So like on this example, we got the 8. 8 plus negative 4. If you would rather see it as 8 minus positive 4, you could. Or 17 minus negative 3, right? Subtracting a negative is the same as adding a positive. So instead of writing 7 minus negative 3, if you'd prefer to see it as 7 plus 3, you could. Again, it's all about being able and having the skill to manipulate these math problems to be exactly what you want them to be. All right, here's 3 problems. We're going to give you guys 1 minute. See if you can solve these 3 problems, okay? 1 minute, go. So this negative 14 minus 8, I would personally write that as negative 14 plus negative 8, okay? And this way I know that my answer is getting more and more negative. So I'm going to keep the negative, and I'm going to take the 14 and 8 and add those 2 values. So 14 plus 8 is 22. My final answer, negative 22. In this next problem, I would change the minus and negative into a plus, which would rewrite the problem, not that you'd have to, as negative 19 plus 3. Now in this case, I know I have more negatives than positives because it's an addition problem. And from here, again, we take the big number, 19, and subtract the 3, the smaller number, which is 16. So that's a negative 16. And that next problem is going to work the same. I got a minus negative 10, so I got to change that to a plus 10. 12 plus 10 specifically. And 12 plus 10, again, if you wanted to do that vertically, you could. 12 plus 10, 2 and 2, positive 22. All right, I already don't remember if we saw into this in 1.0, but a subtraction in order of operations. Fair enough. Well, with subtraction in order of operations, it just falls in with addition and or subtraction from left to right. So the first thing I would look at this problem still is parentheses, which we have. And in this case, I got 6 minus 10. Again, you could write that as 6 plus negative 10. And again, I'm not really focused on the rest of the problem, just the 6 minus 10. Now, on this part of the problem, I have adding opposite signs, and there's more negatives than positives. So I do 10 minus 6, which is 4. So the new problem now, 8 minus negative 4 plus 2. Oh, I forgot my square there. There we go, to the power of 2. All right, so yeah, we do have the exponent there, which is negative 4 times negative 4. And we'll look at this more in the next couple sections, but a negative times a negative is a positive. 4 times 4 is 16. So now I've got 8 minus that 16 plus 2. And that takes care of the exponents. I don't see any multiplication or division. So moving from left to right in subtraction or addition, I got 8 minus 16, which again I could write as 8 plus negative 16. I just want to know that because I know I have more negatives, which makes my answer negative. And 16 minus 8, big number minus a small number, is 8. So 8 minus 16 would be negative 8, but then we got that plus 2 there. And finally, negative 8 plus 2. I have more negatives than positives in this addition part, so I know my answer is a negative. Then I do 8 minus 2, big number minus a small number, is 6. So my answer there is negative 6. So subtraction and word problems, these are some key words you're gonna want to look for. Difference, take away, maybe something's been removed or fallen, like a temperature, right? Or decreased. Debt could be considered a form of subtraction, or going further below sea level or down in sea level. Down would have been a good word to put in this list. If you see less than or subtracted from, those two have asterisks next to them because if it's read as, for example, 8 less than 5, or let me rephrase that, 5 less than 10. Like if I said you had $5 less than 10, you wouldn't do 5 minus 10. It would be 10 minus 5, okay? That changes the order of things, which we're going to have to see in a different section. All right, here's your sign. So what is the sign of the answer when subtracting two negatives? Well, if you're subtracting two negatives, it depends. It depends on, are you subtracting a bigger negative or a smaller negative? Because if you're subtracting a bigger negative, then you end up with a positive answer, right? Because subtracting a negative is really addition. If you subtract a negative from a positive, what's the sign of that answer? It just, again, this one depends on how big. Oh, I take that back. Subtracting a negative from a positive. Let's look at what that would look like. So it'd be like 5 minus negative, whatever, 8, right? If you're subtracting a negative from a positive, this answer is always positive, because by taking away negatives, you're really adding to what is already positive. That's good. I'm glad I read that a second time. Part C, the difference between a number and its opposite. The difference between a number and its opposite. So let's look at any number and its opposite, like 10 and negative 10, right? The difference between these. Well, what's going to happen when I find the difference between these? I'm going to get, well, in this case, it'd be more negative. That'd be fine. But what if it was written the other way around? What if I did 10 minus negative 10, like here at the top? Well, then it'd end up being positive. So it depends on the order, on which one you have listed. So looks like the sign of the leading number would be the sign of the answer.
What is 10 times negative 10?
Then part D, subtracting a positive from a negative. Subtracting a positive from a negative. That's always going to be negative, right? If we looked at an example of that, subtracting a positive from a negative. So you take a negative, any negative, negative 15, then you subtracted a positive, like, again, 8, I guess. Again, this is going to make that more negative because it's like adding a negative answer. Subtracting positives is the same as adding negatives. So yeah, this one is always going to be negative. This one's always positive. The other two, it just depends on how it's written.